All right, so we're continuing on with our discussion on bias. We're still in the collecting data unit and we're continuing with bias. So non-response bias, that occurs when we actually do select a member of the population, but they, for whatever reason, are not responding. Okay, we sent out a letter and they chose not to respond. Okay, this is different than voluntary response bias. Voluntary response bias, we didn't select them to participate, they chose to participate. So voluntary response bias, someone chose to participate in the survey, we just put it out to the public, no one was selected. Here we use some sort of randomization process to choose who we're going to send the survey to, but then the person, for whatever reason, didn't get the mail or refused to participate in our survey. So to determine the average number of children living in a single-family home, a researcher picks a simple random sample of 50 such homes. However, even after one follow-up visit, the interview is unable to make contact with any in the 30 of these homes. The average number is determined to be 2.13. Is this estimate too high or too low? All right, so let's think about this. If I knock on the doors, are families that have a lot of people or few people living at home likely to answer the door? And the answer is, typically speaking, if it's only one person there, they may or may not be home. You only have a shot at one person. But if there's a whole family living there, then you have a much greater likelihood. So chances are this is going to overrepresent, all right? All right, so, and this is too high because of non-response bias, all right? So too high because we were not able to get a hold of 20 of the homes. So that would be non-response bias. And you're like, well, didn't that lead to undercoverage? Yes, it did lead to undercoverage. So if they'd had both of those, we'd have a problem. But too low because of undercoverage? No, it's not low because of undercoverage. It'd be too high because of undercoverage. Too low because of non-response? Wasn't too low, it was too high, so it can't be that. Too low because of convenient samples? Not a convenient sample. Too high because voluntary response bias overrepresent average result. The best answer is too high due to non-response bias, all right? Because they did not answer, all right? Too high because they did not answer. This was not voluntary response bias, okay? If undercoverage bias were there, then we'd have to make a choice, but I still would have chosen non-response bias. All right. Undercoverage bias occurs when members of a population cannot be chosen. All right, so please notice that in the previous one, we were able to choose them, they just chose not to respond, or we weren't able to contact them, all right? So to determine the average number of children, and so once again, I'm working with the same problem. However, even after one follow-up visit, the interviewer is unable to make contact with anyone in 8 of these homes. Concerned about non-response bias, the researcher picks another simple random sample and instructs the interviewer to keep trying until contact is made. So basically, they have bad data, and so now they're adding more data to it. You cannot fix bad data by increasing the sample size. So once again, this is likely to be too high because the ones who answer the door are those who have more family. So too high because voluntary response samples overestimate the average response. So this would be a situation we'd be in trouble if they had non-response bias here, because it would make it very difficult, but I don't think that will ever happen. All right, it'd be very difficult to determine between those two. Oh, and excuse me, this should not have said too high because of voluntary response bias. It's too high because of under coverage bias. I should have made the change. This should have been too high, but please write that down. Oh, there it is. It's letter C. So this is incorrect. it's not voluntary response bias. It's too high because of undercoverage bias. My mistake. Sorry about that. Okay. So which of the faults do the sampling designs have in common? The New York Times plans to make a prediction for the Republican presidential nominee based on a survey of its readers. Well, the problem with this is it's only surveying its readers, and that's a select group of the population, so it's not representative of the entire population. So of those who would make a selection, only those of the New York Times who read the New York Times. An internet site asked viewers to vote on their choice of movie of the year. Well, this is voluntary response bias, so that only those who with strong opinions are going to support it. A statistics teacher randomly picks a sample of his students and interviews each one concerning the clarity of the teacher's explanations of new concepts. Well, quite frankly, because I would be the one doing the interviewing, students are going to tell me what they think I want to hear, so they're going to tell me that I did a great job, even though I may have done a horrible job. So this would be a situation of response bias. 300 Reagan parents were randomly selected to complete a survey about how they felt the school was handling distance learning. Of the 300 parents, only 60 responded. Well, we randomly made a selection, so it's because they were selected. They didn't self-select, so this isn't voluntary response bias. They were selected but chose not to respond, so this would be non-response. So the problem here is all of the designs have errors that could lead to strong bias. There's not one specific error, but they all have introduced bias into the situation. Okay, sampling error. Bias is, first off, let me back up. Bias is a result of a bad design or bad execution of a design. Sampling error occurs naturally. It occurs in every single study that we ever do, and it's because we're using a sample statistic to estimate the actual population parameter. So it's an estimate. And so since every sample, because if you took a sample and I took a sample and we both took them correctly, your sample and my sample are likely to be different, okay? We put everyone's name in a hat and draw, you're not going to draw the same names I did, most likely. So that's sampling error, all right? So sample error decreases as sample size increases. Sampling error can be described using probability. In other words, because it can be described using probability, we can estimate it. We kind of know what it is. I'll let you read the rest of this, but I will say this. It's where the idea of confidence interval widths come up. As we increase our sample size, our interval becomes more narrow. We're more sure about it. Whereas if we have a small sample, we're going to have a wider interval because we're less sure that we were successful in capturing the confidence, or capturing the population parameter. And as I said, sampling error is due to the fact that samples vary because samples are subsets, where bias is part of a poorly designed study. Sampling error decreases as the sample size increases. However, we can never eliminate sampling error entirely unless we are able to conduct a census so that we know the true population parameter. Please recall what happened to our confidence intervals, and we just talked about that. So let's look at some questions. A television network conducts a weekly survey to determine the proportion of viewers who watch various programs for the coming year. And they decide to double their sample size. The main benefit of this is to reduce undercoverage bias. That's false. You cannot eliminate bias or reduce bias by changing sample size. If it's bias, it always stays bias. Next one, reduce bias. Can't be that one because sample size doesn't chase it. Eliminate sampling error. That sounds right, but it's incorrect. You can never eliminate sampling error. You can only minimize it. The next one, decrease the population variability. Hey, we're decreasing variability. That's good, and sample size does that, but you will never change the population. The population is what it is, so that can't be. Decrease the variation of the sample. That is our answer for this one. All right. Sampling error is the standard deviation of a sample statistic. No. The standard error of a sample statistic. No. The difference between a population parameter and the estimate of that parameter. That is sampling error. All right? The reason that's not the first two is because we're going to have variation between people. So again, if we went to income, we're going to have high income and low income, and our sample should also have high income and low income. So consequently, there will be a standard deviation in the sample. All right? So this is because a sampling error is the difference between what our sample says and what for our sample statistic says versus what the population parameter actually is. It's not the result of bias, and it's not that. Which of the following statements about sampling error is incorrect? Sampling error concerns natural variation between samples is always present and can be described using probability. Well, they asked for incorrect, and this is actually true. So that's not my answer. Sampling error can be eliminated only if a survey is both extremely well designed and well conducted. This is false, so this is not likely to be my answer because we can't eliminate it. Sampling error is generally smaller when the sample size is larger. This is true. Sampling error is unrelated to bias. That is true. Sampling error is greater when working with higher confidence level. Not really what we're talking about, but that is sampling error is greater. I should say margin of error is greater when working with, so change out sampling error and write margin of error is greater when working with a higher confidence level. So letter B is my best answer. Letter B is the best answer. All right. And that will conclude this video.